This is 3i Atlas. This is Mars. 3i Atlas is about to swing by, and a fleet of camera-ready rovers and orbiters are standing by to snap some pictures.
Just weeks ago, astronomers thought the 3i Atlas would quietly pass Mars. Instead, it erupted.
Pixel size of 30 kilometers when 3i Atlas was closest to Mars.
Shining 6 times brighter than expected and forming a massive green cloud. Now, racing toward Mars at nearly 70 kilometers per second, it's vanishing into the solar glare.
A fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
Its chemistry is alien even by comet standards, and its path lines up uncannily for planet flybys. Altogether, these coincidences amount to 1 in a billion odds. Are we watching a volatile iceball, a physics-breaking outburst, or a deliberately steered interstellar probe? A visitor that defies the odds. On July 1st, 2025, astronomers in Chile spotted something unusual. The Atlas Survey Telescope, normally hunting for near-Earth asteroids, locked onto an object blazing through space at 221,000 kilometers per hour. That speed alone was enough to raise eyebrows. But within days, researchers realized they weren't looking at just another space rock. The trajectory told a different story. This thing was moving on a hyperbolic path, not circling our sun like everything else in the neighborhood. It wasn't part of our solar family at all. The 3i Atlas had drifted through the darkness between stars for millions, possibly billions of years before gravity finally caught it and pulled it toward our sun. Only 2 other confirmed interstellar visitors had ever been detected. The first was Oumuamua back in 2017, that bizarre cigar-shaped object that sparked endless debates about whether it could be artificial. The second was 2i Borisov in 2019, which actually looked and behaved like a normal comet. The 3i Atlas was different from both. It spewed gas and dust like a typical comet as sunlight warmed its ancient surface. But something felt wrong from the start. When researchers crunched the numbers using hundreds of position measurements from telescopes worldwide, they found the first major red flag. The orbit of 3i Atlas lines up with the ecliptic plane of our solar system to within 5 degrees. That's the flat disk where all our planets orbit, because they formed from the same rotating cloud of gas and dust 4.6 billion years ago. But 3i Atlas didn't form here. It came from interstellar space, where there's no preferred direction. Objects arriving from the galaxy should come from completely random angles. There's no reason for an interstellar visitor to line up with our planetary plane, unless something guided it here. The statistical likelihood of this alignment happening by pure chance is roughly 0.2%, 1 in 500. Strange coincidences happen, sure, but this was just the beginning. The timing that makes no sense. Here's where things transition from merely odd to genuinely bizarre. 3i Atlas's arrival was timed perfectly to pass close to Mars, Venus, and Jupiter. Not just vaguely close, but optimized for observation. The trajectory brings it within prime viewing distance of 3 major planets at different points in its journey through our solar system. The probability of this specific timing occurring randomly is 0.005%. That's 0.005 of 1%. More like getting chased by a hippo on a highway. To put it in perspective, this is exactly the kind of trajectory you would plan if you wanted to conduct a grand tour of the inner solar system's major bodies while using minimal energy for course corrections. Natural comets ejected from distant star systems don't do this. They arrive from random directions at random times, following paths determined purely by gravitational chaos and galactic dynamics over millions of years. However, the 3i Atlas arrived like it had a scheduled appointment on its calendar. On October 3, 2025, the comet made its closest approach to Mars at exactly 29 million kilometers. That might sound far away, but in cosmic terms it's remarkably close. Close enough for detailed observation. And here's the thing. An object far bigger than it should be. When the James Webb Space Telescope locked onto 3I Atlas on August 6, 2025, experts found out that the comet's atmosphere was completely dominated by carbon dioxide, with a ratio of 8:1 compared to water. That's the highest carbon dioxide enrichment ever recorded in any comet. In normal comets, water is the big boss, but in 3I Atlas, the spectrum showed massive carbon dioxide at 4.26 micrometers, carbon monoxide at 4.7 micrometers, and even carbonyl sulfide. Water was at just 3 micrometers, only as a minor player. This chemistry suggests the comet formed in the frigid outer reaches of its birth system, far beyond where water ice could dominate, then spent billions of years in interstellar space, preserving this ancient signature. But here's what really has researchers worried. Carbon dioxide comets are wildly unpredictable. They can produce violent outbursts without warning. Pressure builds beneath the surface until the crust fractures and gas explodes outward. Brightness can spike tenfold in hours, and the size makes it worse. Early estimates ranged from 440 meters to 5.6 kilometers across, but recent analysis suggests the nucleus probably exceeds 5 kilometers in diameter. That's Manhattan Island-sized. This makes 3I Atlas at least 1,000 times more massive than Oumuamua, possibly 1 million times more massive. Ejecting something this large from its home system requires extraordinary energy. A near collision with a gas giant, a close stellar flyby, maybe something more violent. Finding an interstellar object this massive suggests either incredible luck or there's something else happening that we don't understand. A time capsule from the ancient galaxy. While researchers debate what 3I Atlas is made of and why it behaves so strangely, another group of scientists has been asking a different question entirely. Where did this thing actually come from? Not just which star system, but which part of the galaxy? And more importantly, how old is it? A new study published recently took a shot at answering that by running the comet's trajectory backward through time. Using data from the European Space Agency's now-retired Gaia Space Telescope, researchers traced 3I Atlas's path back 4.27 million years. They identified 62 nearby stars that the interstellar object likely encountered along the way. Using Gaia's high-definition data on those stars' motions, velocities, and sizes, they ran the calculations to see if any of them significantly altered the comet's orbit. The answer? None of them did. Not a single star in our solar neighborhood can explain the trajectory and mind-boggling velocity of 3I Atlas. One nearby star, measuring about 70% the mass of our Sun, appears to have nudged the comet's path slightly, but by such a negligible amount that it barely registers. This finding led the research team to a startling conclusion. 3I Atlas didn't come from anywhere near us. It's been traveling for an incredibly long time, potentially billions of years, picking up speed through countless gravitational interactions we can't even trace. The team postulates that 3I Atlas might originate from the border of the thin disk, a region where the galaxy's oldest and youngest stars meet. You see, spiral galaxies like the Milky Way organize their stars into two main structures, a thin disk and a thick disk. The thin disk, slicing through the central bulge of our galaxy, contains the vast majority of the Milky Way's stars and all the active star-forming regions. These stars are relatively young and rich in heavy elements, metals forged in earlier generations of stars that lived, died, and exploded, scattering their elemental guts across space. The thick disk, wrapped around the borders of the thin disk, tells a different story. It stopped forming new stars billions of years ago. The stars there are ancient metal-poor relics from when the galaxy was young. If 3I Atlas really did originate from the border between these two regions, the implications are staggering. This comet could be 10 billion years old, more than double the age of our 4.6 billion-year-old Sun. It might have been ejected from the primordial disk of an early planetary system, kicked out into interstellar space when the Milky Way was still taking shape. That would make it a literal time capsule, carrying chemistry and structure from an era when the galaxy looked nothing like it does today. Of course, the study comes with major caveats. By focusing on nearby stars, the analysis only accounts for a few million years of the comet's potentially billion-year journey. That's like examining the last 10 seconds of a feature-length film and trying to guess the entire plot. The exact origin remains highly uncertain, buried under eons of gravitational interactions that scrambled any clear trail back to its birthplace. But here's the exciting part. The outburst nobody predicted. It was September that truly brought the impossible. Astronomers tracking 3I Atlas through routine observations noticed the brightness readings were climbing, but not following the gentle curve predicted by standard models. Then, in late September, the object exploded. Within days, 3I Atlas brightened by a factor of 40, a level of change that's incredibly rare and scientifically significant, happening only once in many thousands of possibilities. Magnitude estimates dropped from the mid-teens into the range of 12 to 13, bringing the comet within reach of mid-sized amateur telescopes for the first time. The Comet Observation Database lit up with alerts from observers worldwide. Amateur astronomers in Australia posted the first flagged measurements, noting the dramatic spike in just 2 nights. What triggered this violent outburst? A solar storm. NASA's forecast model predicted that a coronal mass ejection launched from the Sun on September 19th would strike 3I Atlas on September 24th or 25th. When billions of tons of charged solar plasma slammed into the comet's coma at hundreds of kilometers per second, it created a cascade effect. The impact superheated the outer layers of ice, triggering explosive vaporization. Jets of gas and dust erupted from the nucleus, expanding the coma to monstrous proportions. The cloud grew until it spanned roughly 600,000 kilometers across, nearly half the diameter of the Sun. This wasn't an optical trick. The cloud was real, physical, and growing by the hour. Solar photons scattered off countless ice particles and dust grains, creating a glow visible even from Earth's surface for those with the right equipment and dark skies. The wow signal connection that changes everything. Now we reach the part of this story that sounds like pure conspiracy theory or science fiction, but is actually backed by rigorous mathematical analysis and hard data. Harvard professor Avi Loeb, former chair of Harvard's astronomy department, discovered that 3I Atlas is arriving from almost exactly the same direction in the sky as the famous wow signal detected on August 15, 1977. That powerful radio transmission lasted exactly 72 seconds and was detected at 1,420.4 megahertz, which happens to be the hydrogen line frequency that astronomers use to search for extraterrestrial intelligence. It was picked up by Ohio State University's Big Ear radio telescope and remains one of the greatest unsolved mysteries in the history of astronomy. Astronomer Jerry Amon was reviewing computer printouts of the telescope data when he saw the signal strength, circled it in red pen, and famously wrote, "Wow," in the margin. The name stuck forever. It came from the direction of the constellation Sagittarius. Now here's where everything connects in a way that's deeply unsettling. 3I Atlas is approaching our solar system from nearly that exact same direction, aligned to within just 9 degrees as the WOW signal. The probability of this directional alignment occurring by pure random chance is 0.6%. That's as likely as getting hit by lightning twice in the same day. Now, taken alone, that's not impossible. But remember the other coincidences. The ecliptic plane alignment at 0.2% probability. The optimized planetary flyby timing at 0.005% probability. When you start multiplying these small probabilities together, the combined odds become vanishingly tiny. The chance of all three occurring randomly is less than 1 in 1 billion. Could 3I Atlas have transmitted the WOW signal 48 years ago? Loeb did the actual mathematics. Back in 1977, if 3I Atlas was traveling at its current velocity, it would have been roughly 600 astronomical units from Earth. That's about 100 times farther from the Sun than Earth is. At that distance, with the right transmitter and power source, it absolutely could have sent a signal strong enough to be detected by the Big Ear telescope. The physics works, the geometry works, the timing works. This is not proof of anything, but it's not easily dismissed either. And that possibility has scientists nervous, in a way they rarely admit publicly. The Mars observations nobody expected to see. Between October 1st and October 7th, 2025, spacecraft orbiting Mars had a once-in-a-lifetime chance. 3I Atlas was passing within 29 million kilometers of the red planet, close enough for detailed observation. Mission controllers at NASA, ESA, China, and the UAE scrambled to reprogram their orbiters. This was humanity's best shot at seeing an interstellar visitor up close. NASA's Mars Reconnaissance Orbiter aimed its high-resolution camera at the comet. The images would be 20 times clearer than anything Hubble could capture from Earth. Clear enough to actually measure the nucleus size and see details in the gas cloud surrounding it. Europe's Mars Express orbiter used its stereo cameras and chemical analyzers to study the comet's composition. What molecules was it releasing? What was it made of? Another European spacecraft, the ExoMars Trace Gas Orbiter, pointed its sensitive instruments at the expanding cloud of gas. These tools were designed to detect trace gases in Mars's thin atmosphere. Aimed at 3I Atlas, they could potentially find exotic chemicals never seen in any comet before. But here's the really wild part. Even down on Mars's surface, the Perseverance rover tried to photograph the comet with its cameras. An amateur astronomer named Simeon downloaded the raw images from NASA's public database, stacked them together to reduce noise, and spotted a faint smudge exactly where 3I Atlas should be. The first time anyone photographed an interstellar comet from the surface of another planet. Now here's the frustrating part. NASA and ESA still haven't released the official data from the Mars orbiters. They're processing the images and analyzing the chemistry data. These things take time, but scientists worldwide are waiting impatiently. The metallic composition nobody can explain. Spectroscopic observations picked up something else that made researchers pause. Nickel. Not just trace amounts either, but concentrations unusually high compared to iron. Now, in most solar system comets and asteroids, iron is the dominant player. But 3I Atlas flipped that script. The ratio of nickel to iron came close to what you'd see in industrial nickel alloys. Before anyone jumps to conclusions, this doesn't mean anything artificial is going on. Nature can absolutely crank out high nickel-to-iron ratios under the right circumstances. Meteorites from differentiated asteroids show similar patterns all the time. When molten metal separates during planetary formation, it creates iron-rich and nickel-rich zones. For 3I Atlas, The elevated nickel might tell us its parent body went through partial differentiation before getting kicked into interstellar space. Or maybe the chemistry reflects something even more fundamental: the composition of its birth cloud. Then there's the polarization business. 3I Atlas threw another curveball with its reflected light, showing extreme negative polarization. Most comets display positive polarization at certain angles, a pretty standard behavior tied to how sunlight bounces off dust grains. But this visitor went the opposite way, hard. The strong negative polarization suggests the dust grains have optical properties nobody expected. Maybe they're bigger than typical comet dust. Maybe they're made of materials with different refractive indices than the usual silicates and organics we see in solar system comets. Scientists are still arguing over what it actually means, but it's just one more way this thing refuses to play by the rules. Look, any one of these oddities on its own? Totally explainable through natural processes. But when you line them all up together, they're telling us something important. This object didn't form under conditions anything like what produced our solar system's comets. The 3I Atlas is carrying messages from another stellar neighborhood, and every new measurement is like reading another page from a story written billions of years ago in a corner of the galaxy we'll probably never reach. The perihelion countdown. So what happens next? 3I Atlas reaches its closest point to the Sun on October 29, 2025, at 1.36 astronomical units. That's about 203 million kilometers. This moment, called perihelion, is when things get real. The Sun's intensity hits maximum, and for a carbon dioxide-dominated comet like this, it's make or break time. Will it survive the heat, or will it shatter into pieces? We're talking gigawatts of solar power hammering the surface, causing ice to vaporize at an insane rate. If the structure is weak or porous, the thermal stress could rip it apart. History shows us it could go either way. Some comets have survived these close passes, battered but intact. Others have spectacularly disintegrated, creating debris clouds that fade away forever. And carbon dioxide ice sublimates way more easily than water ice, which means 3I Atlas could be outgassing more violently than its size would suggest. This could either create a protective dust crust that saves it, or undermine the whole structure from within. Here's the frustrating part. Perihelion happens when the comet is hidden behind the Sun. We literally can't see it during the most critical moment. Ground telescopes? Useless. Hubble and Webb? They can't point that close to the Sun either. There's a complete observational blackout from early October through early November, right when we need to see what's happening most. But there's a workaround. ESA's JUICE spacecraft, the Jupiter Icy Moons Explorer, will attempt observations in November using cameras, spectrometers, and particle sensors. NASA's Europa Clipper might join in too, especially with its ultraviolet instruments. These spacecraft are positioned far enough from Earth to bypass the solar glare problem entirely. If 3I Atlas survives, JUICE and Clipper will catch it emerging from behind the Sun and give us our first look at what perihelion did to it. If it's still intact, we get to study how an interstellar object handles extreme solar heating. If it fragmented, the debris field tells us what it was made of and how it was held together. Either way, we learn something we've never known before. November will bring answers we may not want. When 3I Atlas finally emerges from behind the Sun in November, astronomers are going to be glued to their telescopes, checking everything. Did it get brighter? That would mean something exploded. Did it get dimmer and start fading? That could mean it's falling apart or burned through all its gas. Is it still glowing that eerie green from all the carbon dioxide? Or has the color changed completely? Are there now multiple bright spots where there used to be one? showing it broke into pieces? And here's the big one. Did its path change in any way that normal comet behavior can't explain? These next few weeks will either confirm everything we think we know about these interstellar visitors or completely shatter our understanding. After Venus, it'll swing past Jupiter in March 2026, giving us even more chances to study this thing up close. Is this the most significant astronomical discovery of our lifetime? Or just a cosmic coincidence that will fade into obscurity? What do you think is really happening here?